This video on functions will explain what a function is. We will be discussing terms like the domain and the range, and we'll be looking at values of the domain that are invalid, which lead to a restricted domain. So functions are rules that take a set of values called the domain or inputs and turn them into another set of values which we call the range or output. So here's an example. There's our starting values, those are the inputs, that's the domain, and we're going to turn those set of numbers into another set of numbers which we call the range. And the rule we're going to use to turn those numbers into the range is f of x equals 2x plus 1. So f of x is the outputs, they're the range values, and it's telling us that these range values are 2 times x plus 1. So each of these x values will be multiplied by 2 and 1 will be added to give us a set of range values. So if x is 10, 2 times 10 plus 1 gives us 21. If x is 4, 2 times 4 plus 1 gives us 9. If x is 0, that will give us 1. If x is 9, that will give us 19. Note, I've just put 19 up there, just to be clear, there is no significance in where you place these numbers. If x is 7, 2 times 7 plus 1 is 15. If x is negative 5, times by 2 is negative 10, and then add 1, that's negative 9. If x is 1, timesing by 2 and adding 1 will give us 3. If x is negative 2, timesing by 2 and adding 1 will give us negative 3. 3 will become 7, and 1.5 will become 4. You've seen something similar to a function before. If we were asked to complete the table of values for y equals 2x plus 1, if x were negative 1, y would be 2 times negative 1 plus 1. 2 times negative 1 is negative 2, plus 1 is negative 1. If x were 1, timesing by 2 and adding 1 would give us 3. If x were 3, 2 times 3 is 6, plus 1 is 7. And finally, if x were 5, y would be 11. So y equals 2x plus 1 and f of x equals 2x plus 1 means the same thing. And f of x equals 2x plus 1 can also be written using the following notation. And that means the function f such that x becomes 2x plus 1. So those three expressions all mean the same thing. We're now looking at the notation f of a. Very simple to understand, it just needs remembering. F of a means put the value of x equals a into the function. Here's an example. Our function f of x equals 3x subtract 1. That means 3 times x subtract 1. F of 2 means put the value x equals to 2 into the function. And that will give us 3 times 2 subtract 1. 3 times 2 is 6. Subtract 1 gives us 5. In part B, f of negative 5 means put the value of x equal to negative 5 and put that into the function. That will then become 3 times negative 5, subtract 1. 3 times negative 5 is negative 15, subtract 1, negative 16. And that's exactly what we have been doing previously. Here, our value of x equals 10 was our starting value. We put it through the function and it came up with a value of 21. So in actual fact, 21 could have been written as f of 10, i.e. the value of the function when x equals 10. Similarly, in this question here, when x is 3, y turned out to be 7. And that could have been written as f of 3, the value of the function when x equals 3. Now, this is about finding the range. The domain is our set of starting numbers, our inputs, and the range is our set of finishing numbers, our outputs. And we may be given a domain and be asked to find the range, i.e. we're given some input values and we're asked to find the outputs. So in this first example, we've got f of x equals 2x plus 5, and then we have that notation there. That means our x values are between 0 and 4. X could actually equal 0 because of the little or equals to there. So x is greater or equal to 0 and less than or equal to 4. So our possible x values will look like this. There are inputs, our domain, and we need to find the corresponding outputs, or the range. Well, when x is 0, timesing by 2 and adding 5 will give us 5. When x is 1, timesing by 2 and adding 5 will give us 7. When x is 2, we will end up with 9. When x is 3, we'll obtain 11. And when x is 4, doubling and adding 5 will give us 13. We need to be careful with example 2. First of all, we need to note that the function equals x squared plus 1, and that's a quadratic curve, not a straight line. And therefore we need to sketch the graph, and it looks something like this. The second point to note, our x values are between -3 all the way up to 3. So we mark those two values on the x-axis with vertical lines at -3 and 3. We therefore can trim the graph so that there's no part of the graph less than -3 and no part of the graph greater than 3, like that. Now remember, we want the range. The range are the y values. So if you have a look at the actual red curve, what is the highest value of y you can see, and what is the lowest value of y? Well, the curve runs through that yellow shaded area. And the lowest value of y is at the bottom of the curve there, and that is where y equals 1. And therefore, f of x, or our y values, are greater or equal to 1, because they start at 1 and the curve goes upwards from there. The highest possible y value on the curve is up at 10, and therefore f of x, or y, is less than or equal to 10. And we can check that by putting x equals 3 into our function. If x equals 3, we get 3 squared plus 1, which is 10. That's our y value that goes with x equals 3. Similarly, if we put -3 in our function, -3 squared is positive 9, plus 1 is 10. So when x is -3, y will be 10. That's that value there. So now our range, our y values, are between 1 and 10. And that's how we would write it. And let's just check. F of x less than or equal to 10. That's what we have at the top end. And also, if f of x is greater or equal to 1, as we have here, that's the same as saying 1 is less than or equal to f of x. So these two things are exactly the same. And that's how we'd write the answer. Once again, in example 3, have a look at the function. It's a quadratic, so we sketch the graph. It looks like that. We then look at our x values between -3 and 2, and we mark those on. X equals -3 gives us a y value up there. We'll find out what that is in a moment. And x equals 2 gives us a y value here, and we'll find out what that is in a moment. So we now cut the graph so that nothing exists below -3, nothing exists above 2, and our y values range through that yellow shaded area. We can see the lowest point on the graph, and that's at -2. So f of x is greater or equal to -2. And the highest y value is up at 7. So f of x is less than or equal to 7. And just to be absolutely sure of what that y value is, we put -3 into the function. -3 squared is +9, subtract 2 is 7. And so we have f of x is between -2 and 7. Let's just check. F of x is less than or equal to 7, correct. And f of x down here is greater or equal to -2, and that's the same as saying -2 is less than or equal to f of x. These two things are the same thing. Our next section is restricted domains. Restricted domains refer to certain x values that are not allowed, and these arise from two mathematical realities. Firstly, you cannot divide by 0, and secondly, there is no square root of a negative number. Let's look at both cases. Case 1, you cannot divide by 0. So suppose g of x, I've just changed the notation from f of x to g of x, the letter doesn't matter. G of x equals 3 divided by 2x subtract 1. Now we cannot divide by 0, and we're dividing by 2x subtract 1. Therefore, 2x subtract 1 cannot equal 0. And that's the notation there for cannot equals, an equal sign with a line through it. If we add 1 to both sides, that means 2x cannot equal 1. And if we divide by 2, x cannot equal a half. And therefore, x equals a half is the value that we cannot have. X cannot equal a half because if x does equal a half, it will make this denominator 0, and you can't divide by 0. Similarly, if h of x equals 5 divided by x subtract 4, we're dividing by x subtract 4, and because we can't divide by 0, x subtract 4 cannot equal 0. And if we add 4 to both sides, it's telling us x can't equal 4. So the value of x for which that function is not valid is x equals 4. In case 2, there is no square root of a negative number. So if our function g of x is the square root of 3x subtract 1, we've got the square root of 3x subtract 1. Now, 3x subtract 1 cannot be a negative number because we can't have the square root of a negative. Now, for a number not to be negative, it must either be 0 or greater than 0. And therefore we write that 3x subtract 1 has to be greater than or equal to 0. We then add 1 to both sides, so 3x is greater or equal to 1, and divide by 3, x has to be greater or equal to 1/3. So to make this function valid, our x values have to be greater or equal to 1/3. In our second example, suppose h of x equals 5 subtract x. Once again, we've got the square root of 5 subtract x, and that square root can't be a negative. We can't have the square root of something that's negative. So 5 subtract x must either be 0 or greater than 0. So we write 5 subtract x is greater or equal to 0. Adding x to both sides gives us 5 is greater or equal to x, but we should start our inequality with x, and if 5 is greater or equal to x, that means that x is less than or equal to 5. And that's how we end up with restricted domains.